Hello and welcome back to our series of videos on chemistry revisions. This is our third video on mole calculations or chemical calculations. You may wish to look at our first two videos where we give you some basic examples of how to do chemical calculations. Okay, so before we start, let us again revise the steps that we need to use for us to solve problems involving chemical calculations. So we always start with writing a balance equation, a balanced chemical equation. We write down the mole ratio of the reactants and the products from the balanced chemical equation. We write down the moles of the substance. We calculate the number of moles of the given substance. We then use the mole ratio to determine the number of moles of the unknown. And lastly, we use that number of moles to find the mass or the volume of the unknown that we wish to find. Okay. Now we are introducing a new formula here, which is the formula for concentration, relating concentration to number of moles and volume. So let us see how we can use this in all these formulas in our calculations. So let's take a look at the third example that we are doing in this series. Alkalis react with ammonium salts to produce a salt, ammonia gas, and water. Okay, so the equation gives you the reaction between sodium hydroxide and ammonium sulfate to give you sodium sulfate, ammonia gas, and water. Okay, so now given that 16.5 grams of ammonium sulfate was reacted with 2.0 mole per dm cube of aqueous sodium hydroxide, find the volume of sodium hydroxide used, the mass of the sodium sulfate in the reaction, and the volume of ammonia produced at room temperature and pressure. Okay, so it looks complicated, but we always follow the steps given. So let us follow step one. Write a balanced chemical equation. Now in this case, the chemical equation is already given to you, but let us write it down anyway. 2 of sodium hydroxide reacts with ammonium sulfate to produce sodium sulfate and ammonia and water. Okay, so step 1 is done, which is simply writing the balanced chemical equation. Okay, now let's do step 2, where we write down the mole ratio of the reactants and the products. Okay, so step 2, we write down the mole ratio. So the mole ratio, we can see here that 2 moles of sodium hydroxide reacts with 1 mole of ammonium sulfate to give you 1 mole of sodium sulfate and 2 moles of ammonia and 2 moles of water. So this is your step 2, where we write down the mole ratio of the given reactants and products. Okay, so now let's just see what we can do about step 3. Step 3, we calculate the number of moles of the given substance. So let's write down what has been given to us. Okay, we have been given some information on ammonium sulfate. This is the mass of ammonium sulfate, and we know that we are given 16.5 grams of ammonium sulfate, and we are also given some information on the aqueous sodium hydroxide, which is the concentration. So we know that 2.0 mole per dm cube concentration of sodium hydroxide was used. Okay, we are asked to find the volume. So what is the volume of the sodium hydroxide that was used? Okay, so we have written down the given information. So now let's calculate the number of moles of the given substance. Now we are given some information on sodium hydroxide, but we can't really do much with it because we do not know the volume, but we are given the mass of ammonium sulfate that was reacted. So we can now calculate the number of moles of ammonium sulfate. Okay, and we will use the formula which is given here, which is mole is equals to mass divided by mr from this little triangle. Okay, so we calculate Mole is equals to mass over mR. Mass given is 16.5. mR of ammonium sulfate. Now let us calculate that together. Okay, in order for us to save space, perhaps we will write down here. Okay, mass over mR. Mass given is 16.5 divided by mR. Now nitrogen is 14 plus hydrogen, that's 4, so that's 4 times 1. Okay, we multiply all that by 2 because there's 2 of ammonium, and we add 32 for sulfur, and we add 4 of oxygen. So that will give us the mR of ammonium sulfate. Okay, so this will give us 16.5 divided by 132, and this will give us the number of moles to be 16.5 divided by 132 is 0.125 mole. Okay, so we know that 0.125 mole of ammonium sulfate reacted in this reaction. Okay, so now let us see, we have completed step number 3. We now use step number 4. Using the mole ratio, determine the number of moles of the substance that we wish to find. Now in this particular case, the first item we need to find is the volume of sodium hydroxide. Okay, so let's calculate. We know that the mole ratio of sodium hydroxide, okay, so now I'm doing step 4, mole ratio of sodium hydroxide to ammonium sulfate was 2:1. Okay, now we have already calculated the number of moles of ammonium sulfate here was 0.125 mole. Therefore, how many moles of sodium hydroxide reacted? It will be 2 times 0.125 mole, because the mole ratio is 2:1, and that will give you 0.25 mole of sodium hydroxide. Okay, so we now know that moles of sodium hydroxide reacted was 0.25 mole. Okay, so now that we know that 0.25 moles of sodium hydroxide was formed, can we calculate the volume? Yes, we will use this formula where concentration is equals to mole divided by volume. But in this case, since we're looking for volume, we will use volume is equals to mole divided by concentration. Okay, so the volume of sodium hydroxide used is mole over concentration. Now we know that there is 0.125 mole of sodium hydroxide formed, which is here. I'm sorry, 0.25 mole, not 0.125, divided by the concentration, which was given to be 2 mole per dm cube. So this is 2. So this is 0.125. Now we are talking about volume, and we've been using dm cube, so this volume is actually in dm cube. But if we are asked to find the volume in cm cube, we multiply by 1000. 25 dm cube times 1000 cm cube. This will give us a volume of 125 cm cube. Okay, so we have solved the first problem. Okay, you notice that we have been closely following the steps shown in the top of the paper, okay, the top of the worksheet. Okay, so we have already done step number 5, which was actually here. Okay, so we have solved part A. Let us now solve part B. The mass of sodium sulfate produced in the reaction. We are now looking for the mass of sodium sulfate. Now, we know that the mole ratio of ammonium sulfate to sodium sulfate is 1 to 1, right? Given from the mole ratio in step 2. 1 mole of ammonium sulfate reacts with 1 mole, reacts to form 1 mole of sodium sulfate. Okay, so in part B, we can tell that the number of moles of sodium sulfate formed will be the same as the mole of ammonium sulfate, which we have calculated here. So we know that there is 0.125 mole of sodium sulfate formed. Okay, and in order for us to calculate the mass of the sodium sulfate, we again turn to our formula. Where is the formula I'm going to use? Which is here. Okay, so mass will be equals to mole times mR. Okay, so we simply do mole, which is 0.125, times the mR of sodium sulfate. Okay, now sodium will be 2 times 23 Na2 plus 32 of sulfur plus 16 times 4 of oxygen. So allow me to rewrite that. 4 multiplied by 16 of oxygen. So this will give us 0.125 multiplied by 142, and this will give us a mass of 17.75 grams of sodium sulfate formed. Okay, so you can see that I've been following the steps very closely. If I had done the steps 1 to 4 correctly, step 5 will be a breeze. Okay, so now that we've solved A and B, let us do C. The volume of ammonia gas produced at room temperature and pressure. So again, we notice that here 1 mole of ammonium sulfate reacts to give you 2 moles of ammonia. Again, we go back to the mole ratio. Okay, so since we know that there is 0.125 mole of ammonium sulfate used, we will get 2 times 0.125 mole of ammonia. So let's write that down. Part C, okay, allow me just to extend a bit. Okay, so part C, moles of ammonia formed will be 2 times 0.125 mole, since the mole ratio of ammonium sulfate to ammonia is 1:2. So this will be give you 0.25 mole of ammonia. Okay. Now, in order for us to find the volume, we will use this formula. So volume of gas is equals to mole times 24 dm cube. So the volume of the gas, volume of ammonia, will be mole times 24, which is 0.25 times 24 dm cube, and this will give us 6 dm cube of ammonia. Okay, so it may look complicated again, but I assure you that if you follow these steps here very diligently, you would be able to solve most, if not all, problems involving mole calculations. So again, let us recap the steps that we need to take. Okay, we always start off with the correct balanced chemical equation. Now, allow me to warn you that if you write a wrong chemical equation and it's not balanced, everything else that follows will be wrong. So it's very important to start off with the correct balanced chemical equation. We then write down the mole ratio of the reactants and the products as given in the chemical equation. We write down the number of moles of a given substance. There will always be one substance that's given. It could be either the reactant or the product. Okay, then we use the mole ratio to find the number of moles of the unknown, and you can see why that if I had written the wrong chemical equation, I would have the wrong mole ratio and I would have the wrong moles of the unknown. Okay, so it's very important to start off with a correct balanced chemical equation, and then use step 5 to just determine the unknown. Okay, so I hope that this video has allowed you to see the proper steps that we need to take in order for us to solve problems involving chemical equations. Okay, so look out for our next series of videos when we handle chemical equations involving excess and limiting reagents. Okay, so see you soon. Bye.